Okay, so today we are going to learn about some exponent rules. Okay, and just to refresh what an exponent is, so for example, if I have 3 to the 4th power, that would mean that I'm repeating multiplication. So that would be 3 times 3 times 3 times 3. And of course, if I wanted to work that out, 3 times 3 is 9. This 3 times 3 would also be 9. 9 times 9 would be 81, would equal our 3 to the 4th power. So exponents just represent repeated multiplication, just to make sure we're on the same page. If I had 2 to the 6th power, that would be 2 times 2 times 2 times 2 times 2 times 2. So 2 times 2 would be 4. This 2 times 2 would be 4. This 2 times 2 would be 4. If I multiplied these two together, I would get 16 times 4. And 16 times 4 there is going to give us 64. So 64 is what this would be equal to. So exponents just mean repeated multiplication. Now let's look at what this is going to look like when we have variables with it. So what you're going to be seeing here are problems like example 1. You're going to see something like x to the 4th times x to the 3rd. And so whenever we're dealing with x to the 4th times x to the 3rd, we have repeated multiplication here. So I'm going to show you how to do this the long way, and then we're going to look for a shortcut. So the long way would be to write it out. So when I see x to the 4th, that means that I've got x times x times x times x. So x 4 times. And then for x to the 3rd, that would be times x times x times x. So I've got x to the 4th, meaning that I've got 4 x's right here. And then I've got x to the 3rd, which means I've got 3 x's right here. And so if I combine those all back together, I could write this as x to the 7th, which means I've got x multiplied 7 times, which is what I've got here. So notice there I just added that 4 and that 3. So if I had a problem like x to the 2nd times x to the, well, let's not do 5th, let's do 4th here. If I had that, then I could, again, do this the long way. I could right here and have, this is x times x for my x to the 2nd power. And then I could have, I've got 4 x's here, 1, 2, 3, 4. So 4 right here. And then so when I put those all together, I've got 1, 2, 3, 4, 5, 6 x's. So I would say that's x to the 6th power. So you can start to see a pattern here. Whenever we do these problems, if we have x to the a power times x to the b power, it is going to equal x to the a plus b power. So what this is telling us right here is that when we are multiplying terms with like bases, we can just add the exponents. Okay, so so you do have to have the same base. So you notice I had x's in both of these places. So if, for example, if I was trying to do a to the 3rd times b to the 5th, I could not do that because those are not like terms. I could not write the a's and the b's together and say this is something like ab to the 8th or something like that. That would not work. So you have to have the same base here. Now, let's look at what this looks like whenever we have a coefficient in front. And so I'm using that fancy word, coefficient. And that just means a number that is multiplied by one or more variables. So, for example, this means that I'm going to have something like this, 3x. And so we would call this number right here, the 3, we would call that the coefficient. And then, of course, this x right here would be my variable. For another example, maybe I've got negative 5x squared times y. In this case, that negative 5 is my coefficient. Of course, the x squared y here, sorry, this x, this x squared y, those would be my variables. That might seem unimportant to you, but it is really important because you're going to see those words used a lot, and you need to know what we're talking about when we use that word coefficient. Plus, it just makes you sound fancier and smarter if you use big words like that. So, coefficient is an important word. So, let's look at what happens when we have coefficients in front of our numbers. So, for example, 3. I want to do this problem. 3x times negative 4x to the third power. Alright, so when we're doing this problem, again, I'm going to look at this the long way. So right here I've got 3x. That x does not have a power, so I could think like I'm putting that to the first power right there. So I've got 3 times x, and then for this part, I would have negative 4 times, I got 3 x's, 1, 2, 3. And of course, whenever we're multiplying things, it's okay to mix the order around. So I could also write this way. 3 times negative 4. I could put the numbers together up front, and then I would have my blue x here times my 3 red x's over here. And so if I look at that now, I can just multiply these two numbers together. So I would have negative 12, and then I've got 1, 2, 3, 4 x's. So I'd have x to the 4th power, and that would simplify this expression for me. Now, that's the long way. I don't expect you to do that every time. So what I would like for you to work up to doing here is, if you have a problem like 7x to the 5th times 3x squared, like so, you can see we can multiply those coefficients together. So 7 times 3 is going to give me 21. And then we're going to multiply our x's together. So x to the 5th times x squared is going to give us x to the 7th. We add those exponents together there. So in this case, we multiply the coefficients, those big numbers, the 7 and the 3 in this case, and we add the exponents. Let's try one more here. I'm going to throw something a little bit different in on this one. Let's say that we had 4xy squared times, let's make it a negative 4 times negative 3x y to the 4th z here. So whenever you're doing a problem like this, you have to multiply together the parts that go together. So we can start with our coefficients. Negative 4 times negative 3 is going to give us positive 12. Then remember with these x's right here, and the z over here as well, they look like they don't have an exponent. But if they don't have an exponent written, it means there's an exponent of 1 because there's one x right there. We could also put a 1 over there on the z if we want, although it'll be a little bit less important. So we're going to put all of the x's together. We have to deal with a like basis. So I've got one x here and another x here. That's going to give me x to the 2nd. Then I look at my y's. I've got 2 y's here and 4 y's here, which is going to give me y to the 6th, just adding those exponents together. Z, I've only got this one single z. There's not a z over here, so it's just going to be sort of tagged on the end right here. So this would be our answer for example 6. All right, let's look at another situation that we're going to run into. So for this situation, for example 7, we are going to have something that looks like this. X to the 3rd to the 2nd power. Okay, so let's think about this the long way here. So when we see x to the 3rd raised to the 2nd power, what that means is that we're doing x to the 3rd times x to the 3rd. Now at this point, we could use our rules. 3 plus 3 is x to the 6th, and that would give us our answer. Or if we want to write it out the really long way, x to the 3rd would be x times x times x. And then here we'd have x times x times x again, which of course would give us that x to the 6th also. Let's try another one. We've got example 8. For this one, let's have b to the 2nd power raised to the 5th power. Okay, so when we see this, again, thinking the long way, that means b squared times b squared times b squared times b squared times b squared. And if you really want to write this the long way, each one of those b squareds, that's b times b. So you got this one. Then you'd have another b times b right here. We have b times b right here. You have b times b right here, and then finally b times b right here. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 b's. So b to the 10th power would be our answer. So we would rather not have to do this the long way. So if we summarize this in an easier rule, if we have x raised to the a power, and then that is raised to the b power, it is going to equal x to the a times b. So we multiply our exponents. So let's write that out as a note here. When raising a power to a power, multiply the exponents. Okay, so that means whenever we get to a problem like this, we are going to do, let's say that we have x to the 3rd raised to the 9th power. Now this one would really take a long time to write out the long way, but I know here I'm raising a power to a power. We know we have a power to a power when we have an exponent, and then another little exponent that's even higher than that other exponent. So when we have this situation, we want to raise that power to a power, and we're just going to multiply the exponent. So this would be x to the 27th power here. All right, we've got one more thing that we need to look at, because we need to look at what happens whenever you have coefficients in this particular case. So let's do example 10. And so for example 10, I'm going to take 2x to the third, and I'm going to raise it to the fourth power. Okay, so think about this, and we'll think about it one time the long way, and then we'll just look at what to do after that. So what this means is 2x to the third times 2x to the third times 2x to the third times 2x to the third. So if you can see here, we've got 1, 2, 3, 4 2's. That is 2 to the fourth power. And then we've got 3, 6, 9, 12 x's here. So that'll be x to the 12th. So if we do 2 to the fourth power, that is 2 times 2 times 2 times 2. If you need to, write it over to the side. 2 times 2 is 4. 2 times 2 is 4. If you multiply 4 times 4, of course, you get 16. So the answer for this one would be 16x to the 12th power. So to shortcut that, what we could have done is we could have just raised each number to the fourth power. So let's try one using a shortcut rule there. So let's say that we've got, for example, 11. Let's say that we've got negative 3x to the fifth raised to the third power. Okay, so to do this, we're going to think we're raising both terms to the third power. So that is going to be like this. We're going to have negative 3 raised to the third power, and then we're going to have x to the fifth raised to the third power. And so negative 3 to the third, if we think of over here, negative 3 times negative 3 times negative 3, we would get a positive 9 times a negative 3, which would give me negative 27. So that coefficient is going to be negative 27. And then we've got x to the fifth to the third power. We just multiply our exponents here, so we get x to the 15th. Okay, so with coefficients, we'll make ourselves a little note here. We are going to raise the coefficient to the power, and then we're going to multiply the exponents. Alright, so let's do one more. Let's look at what happens when we have more than one variable inside of our parentheses. So let's say that we have 5xy to the third raised to the, let's go second power here. Okay, so whenever we do this, we're raising every piece to the second power. So that means we're doing 5 to the second power. It means we're doing x to the second power, and we're doing y to the third to the second power. So the coefficient we just raised to that power, 5 to the second power, is 5 times 5. We call it 5 squared. Anything to the second power we can call squared. Anything to the third power we call it cubed. And that's going to just give us 25. So 25. And then x, there's nothing special going on here. We're just going to have x squared. And then here we've got y to the third raised to the second power. So we're raising that power to a power. So that is going to give us y to the 6th. So hopefully this helps you. You are going to do a Delta Math assignment on this particular part. So please go to Delta Math and complete that for me. If you have any questions, let me know.